Hello everyone, welcome back to SMAT1033. In last time we talked about radical function. The index and the end value is even or odd, and it's even we have a typical example of n is even is 2 when we have square root, and n equal odd, and it's odd number, then we have odd root. Cube root is the typical example when n is odd number. And I also talk about some property of radical, right? It helps you to simplify radical expression, which is we're gonna do today. The first property is if we have n root of x to the n, then equal to x. And if we have n root of x to the m, then it equal to x to the m over n. And we know that the fraction right here as the exponent, and this is called a rational exponent. So this is rational exponent, rational exponent. Okay, right up here because it's fraction. But if n going to m evenly, then this is perfect, right? We just have a whole number as the exponent. Okay, so this is rational exponent right here, and the whole thing is rational exponent expression. Okay, expression. Okay, now we also know that if n is even, then we can take root of negative number. That's what we know last time. And if n is odd, then it's okay. It means we can. Okay, I mean we can take root of negative number. Now, today we're gonna learn how to simplify radical expression, and we're gonna use what we already know last time to simplify the radical expression. Okay, so the topic today is called radical simplification. Okay, radical simplification. Okay. All right, let's start with our first example. In the first example, we're gonna have something very simple. Oh, let's see. I think I need to remind you something. Actually, we're gonna need some very important, very simple concept. Actually, the basic concept we already learned. Probably before intermediate algebra, which is called a prime factor tree. Okay, we're gonna use all of the concept we learned last time, and we have something called prime factor tree. I don't know if you still remember. That the prime number is a number that's going to 1 and going to itself. So we're gonna do a prime factor tree. Means we try to find all the prime number of a number inside radical. Okay. So in the first example, I'm gonna give you something very simple. Okay. For example, I want you to simplify this one right here. What if I want you to simplify a square root of 25? Okay, everybody knows square root of 25 will be 5, right? Because 5 times 5 give you 25. How about I want to take square root of 1? I want to simplify a square root of 125. 125. If you do prime factor tree. Okay, I'm going to do prime factor tree. You will see that we have 3 prime number here because 125 you split them to 5 and 25, 25, you split it up again, you give you 5 and 5. So you have 5, you have 3 number 5 here, and number 5 is a prime number. So in order to simplify this, I can write it as because this is the index over here. The index over here is 2. Is 2, right? It's square root. So I'm gonna rewrite 125 as a 5 square, right? Because we have 2 number 5 here. We have totally 3 number 5, but I can write this as 5 square and 5, right? So totally we have 3 number 5. And the reason I want to write as the second exponent because the index over here is 2, and if the index over here is 2 and the exponent is also 2, so you see that we can get rid of the radical, right? So over here is 2, 2. What we have left is just whatever inside. So whatever inside over here will be 5. Okay, but then the number 5 over here we still have inside the radical. There you go. So this is the simplest form of square root of 125. Okay. Now what if I want to do third root? Okay, I want to do third root of negative 81. So this is the third root. This is odd number. So we can do the root of negative number. So this one will give you what? This one will give you so in order to get this, we're gonna rewrite it in the form of the third exponent. So this is square root, so we're gonna write it in the form of second exponent. So this is third root, so we're gonna write in the form of third exponent. So 81, if you go ahead and do prime factorial, you're gonna have that 3 and 27, and 27 is 3 and 9, and 9 is 3 and 3. So we have 1, 2, 3, 4. So over here, because we want to write as the third exponent, so we have 3, 3, 3. We can write as 3 to the third power. Negative, okay, you still forgot about negative. And the inside, we still have another number 3, right? Alright, now because the third root over here and the exponent is the same, so you see that we can go ahead and throw away the radical. We're gonna skip root of negative number, it still works, so give you negative. Okay, get rid of the root and exponent, so you have 3, but the 3 over here is still inside the third root. Alright, so you're gonna have negative 3 times third root of 3 as the final answer. Okay. What if I have this? What if I have a fourth root? I want to find fourth root of 625. Let's just try to do something else. How about fourth root of about how about fifth root? How about fifth root of negative 243? Fifth root negative 243. Okay, so this is the fifth root. I mean, we can take the root of negative number. It could be something like this, but again, in order to simplify it, we gotta write it in the form of fifth exponent. Okay, this is in the form of third exponent, this is in the form of second exponent. Okay, in the form of fifth exponent because the n over here is 5. So we do the prime factor 3. So 243 divided by 3, which is give you 81. 81 divided by 3 give you 3. 27. 27 is 3, 3 and 9, 3 and 3. So you could have like 3, 3, 3, 3, 3. So we have phi number 3, so I can write this as fifth root of negative 3 to the fifth power, right? And you see the index and the exponent the same, so I can go ahead and cancel them out. So what you have left is just negative 3. Alright. Okay. Very easy, huh? Okay. Now the second example, I'm gonna add a little bit variable into the radical. What if I have this? What if I have 16? Hold on. How about I have square root of 32 x to the 8. Alright. So we gotta do prime factor tree for 32. So 32, we know 32 is 2 and 16, 16 is 2 and 8, 8 is 2 and 4, 4 is 2 and 2, so we have 1, 2, 3, 4, 5. So this is square root, so I can write it as 2 square, and 2, right? And if you notice, you will see that x to the 8 over here, and 2 go into 8. So 2 go into 8, 2 go into 8, give you 4. So 2 go into 8 give you 4, so you have 4. X to the 4, right? Because 2 go into 8 give you 4. Exponent here and radical, the index over here is 2, so you cancel that. You have 1, 2, 1 number 2, 2 number 2, which is 4, 2 number 2, 2 number 2, 2 times 2 is 4. So what you have left, is the number 2 inside the radical. So the final answer will be 4x to the 4th power times square root of 2. Okay. So that's how you do it. I mean, the good thing over here is that because 2 go into 8, that's a very nice number, you know. But it's not always like that. For example, if I have something like this, what if I have third root of negative 27 x to the 12 y9 y10, I'm sorry. Okay. So you see that 3 go into 12, so that's good, but 3 does not go into 10 evenly. 27, I can write it use prime factor tree. We know that 27 is 3 times 3 times 3, so basically 27 is negative 3 raised to the 3rd power, right? And it's got 3 going to 12 already, so that's good. We don't need to change anything, but I mean 3 is not going to 10, so I'm going to change y10 is y9 times y, because 3 go into 9. Okay, so 3 go into 9 evenly, so I can apply this formula right here. So cube root of negative 3 to the 3rd, you cancel, you have negative 3. This is 3 going to 12 will be x to the 4. 3 going to 9 give you y to the 3rd. And you still have the y over here inside the cube root, so this will be your final answer. Okay, so you're trying to split it up into something so that 3 go into the exponent. So 10 over here I split up in 9 and 1 because 3 go into 9. Okay, 3 go into 9. Okay, this one you don't have to split up because 3 go to 12 already. If it is 11, you gotta split up. It's an x9, x2 because 3 go into 9. Okay, so you gotta be flexible a little bit. Okay. Now what if I have this? What if I have? I try to find something. How about if I have something like this? What if I have this one right here? In the back of your book, there's a bunch of problems. You can use that to practice. What if I have this? What if I have 100? Well, you know what? I think I'm gonna get it from the other book. I mean, it's kind of the same thing now. Textbook is the same thing. See, intermediate algebra. How about I get it from this one? I think it's better right here. What if I have fourth root of x to the 8 y 13 z 50. What's about this? I want to simplify this. I know the 4 going to 8, that's just good, that's perfect, but 4 is not going to 13, so you gotta split up a little bit. So you gotta split up into 12 and y, because 4 going to 12. The 4 is not going to 15 either. However, 4 is going to 12, right? It's not going to 14. It's not going to 13. It's only going to 12 and 8. So I'm going to split up z15 is z12 times z3. So 4 into 8, so if you go ahead and apply the formula using the property here. So you can see the 4 into 8 give you x star 2, y2, right? For y3, because 4 into 12 will be 3. Z3 also, right? But I mean z3 inside over here you still have it, so you have 4th root of z3. There you go. Okay. Alright. So that's the strategy. I mean, you're gonna split up into something so that the index going to the exponent. Okay. Index going to exponent. What if I have this? What if I have inside is something inside is expression that contain, that is the sum of difference. What if I have x minus 2 inside? Okay, and this is the, so this is fifth raised to the fifth exponent. I know the 4 not, you see the 4 not going to 5, right? So you gotta split up into x minus 2 to the 4, because 4 going to 4. But there's 4 times this is 5 times, so there's another time. Alright, so 4 into 4, you can cancel everything else, so what you have left is x minus 2. But this one is still inside the 4th root. There you go, so that's how you do it. Okay. Sometimes the inside is the algebraic expression that you cannot take square root, simplify right away. For example, you have x squared plus 2x plus 1 inside, and this is square root, and you see that this is trinomial. You have to factor them out. And x squared plus 2x plus 1, if you factor, you're gonna have x plus 1 times x plus 1, and x plus 1 times x plus 1 will be x plus 1 square, and you see the index over here and the exponent will be give you x plus 1. However, because we don't know the inside positive or negative, so the answer should be absolute of x plus 1 in this case. Okay, actually the same thing over here. This should be absolute. Okay, because we don't know it's positive or negative. But I mean, I don't really consider that much. If you put the answer like this, would be okay. But in your MyMathLab, they want you to put in the absolute value because you don't know that it's positive or negative. That's what I mean, you know. Because you don't know a positive or negative, then you gotta put in absolute. Okay, so the best answer actually over here is absolute x minus 2, fourth root of x minus 2. So you gotta be careful. I mean, if the question specify that the x minus 2 is positive, then you don't have to put in absolute. But over here, the question is, you see that I did not specify that the x minus 2 is positive number. So you gotta put in absolute. Same thing over here, you gotta put in absolute. Actually, all of this over here, especially when you're dealing with the, or this one you don't have to, but be careful. In this one right over here, no, this one you don't have to either. None of this you have to do with absolute. But be careful. This one, okay, you have to. Okay, if I specify it's greater than, so this is if I want to keep this, then I have to say that if x minus 2 greater than 0. Okay. Otherwise, this is what MyMathLab want you to do. See that? Okay. If you see something like this, you cannot just go ahead and throw away the radical, even though the index and the exponent is the same. Let me see that last time we just go ahead and throw away and give you 2, and in order to just give you 4. But this one you gotta be careful. Okay. For the fifth root, you don't have to. It doesn't matter for the fifth root because the fifth root is you still can take the root of negative number, so you don't care about the absolute. Okay. Right. Now, in the next example, I'm going to give you something in fractional form. What if I have this? What if I have a cube root of 64 a 3 over b9? Okay, so we know the 64 cube root 64. We try to do a prime factor tree over here. Okay. 32 to 16, 16 is 2 and 8, 8 is 2 and 4, 4 is 2 and 2. So you see that 1, 2, 3, 4, 5, 6. So I can write this 64 as 2 to the 6, right? You know, I don't want to write a 2 to the third, 2 to the third. You can do that, but because 3 going to 6 right away, then you don't have to write 2 to the third times 2 to the third. A3, you keep it there because we know that 3 also going to 3. So this is 3 going to 6, which just give you 2, right? So you're going to have 2 squared, which is 4. And cube root, the 3 over here, so you have A. And 3, 9, which is 3 going to 9 will be B3. Okay? And the reason you have 4 over here, again, the reason you have 4 over here, because 3 going to 6 is 2. So 2 square is 4. Okay? Okay, we use this. 3 going to 6. So 2 and 2 is this. 3 going to 6 is 2. 2 square is 4. Okay? Alright. Example 8. Alright, how about this? What if I want to simplify? Okay, let's see. Let's see. I have something with fraction and I probably don't have anything with fractions. How come I don't have anything with fraction? I should have anything with fraction, right? Simplify radical. Let me see. Oh, there you go. I have something with fraction right here. There you go. Alright. How about I have fourth root of 5 8 b6. Fourth root 5 8 b6. Okay. 80 a3 b2. 80 b a3 b2. 80 a3 b2. All right, you can get a bunch of problems for you to practice in the back of at the end of each chapter in your textbook. All right, fine. First of all, I cannot do fourth root of 5, right? But if I go into 80, simplify this fraction first, so you're gonna have 80 divided by 5 is 16, right? So this will be 16 at the bottom. And a 4 going to 8, so which I'm going to keep it. But 4 not going to 6, so I need to change something. So B over here will be B4, B2, because 4 going to 4. 4 is not going to 3, so I put a 3 here. And 4 is not going to 2 either, so I put B2 here. So you see, you can simplify A3 and 8 and A3 give you A5. You know what? I think I'm going to simplify the first, you know. Yeah, I think I'm going to simplify the first. So A3 divided by A8 divided by 3, you subtract 8 minus 3 will be A5. Yeah, that's better. We already learned the exponential rule. B6, B2 will be B4. Okay. And now 4 is not going to 5. I'm going to go ahead and split them up. 16 is 2 to the 4th. So that's good because 4 going to 4 is A4 times A. So I split up, so the 4 going to 4, B4, 4 going to 4, E. So give you A, B outside, but the inside is 2 outside, but the inside you have fourth root of A. Okay, pretty easy, right? Okay, it's nothing really that bad over here. So you gotta split it up some way somehow, so that you can do division evenly, right? All right, on the example number 9, I just want you to go ahead and simplify it. I want you to go ahead and do it, practice on your own. Okay, so let's see which one I want you to do. How about this one right here? Third root 54 x7 y5. Third root 54 x7 y5 over 54 x7 y5 over 250 x square y square. 250 x square y square. Here you go. Go ahead and try to do this problem yourself. Okay. So the lectures is kind of pretty short. I'm gonna stop the lecture right over here. If you have any question, please let me know, and you can ask me directly in class. Okay, we're gonna do more about radical in class, especially we learn how to add radical, subtract, multiply, and dividing radical very soon next time. Okay, I'll see you next time. Bye bye.